Hi, welcome back. In a previous video, I gave a little introduction to substitution ciphers and how they can be used to encrypt and decrypt simple messages. In this video, I want to demonstrate how to write a small application in Java using a substitution cipher called the deranged alphabet cipher. Now, before we can get to coding, I just want to do a quick review of the deranged alphabet cipher. In a previous video, I explained how the deranged alphabet cipher worked by creating a scrambled copy of the alphabet. It did this by placing each letter at a random location and using each letter in the alphabet only once. Once the scrambled alphabet is created, we have the option of scanning it to fix any duplicated letter pairings. This can be done either by swapping or shifting any matching letter pairs. This step is entirely optional, but it does help to avoid any case where an attacker can easily guess the encrypted message simply because there are just too many matching letter pairs. And finally, the key for the cipher is the scrambled alphabet itself, which means we must have this key in order to encrypt and decrypt our secret message. So, looking at a quick example of how this works, the encryption is performed by taking a secret message and looking up each character in the message in the alphabet. The character is then replaced by its matching substitution pair, and we keep doing this until the message is entirely encrypted. Any characters like spaces and punctuation marks, we're going to carry those over to the encrypted message for now. And decryption is done using the same method, but in the reverse direction. In this case, we start with the encrypted message, and we look up each character in the substitution alphabet and use its index to find the correct letter in the original alphabet. So now that we've talked about the deranged alphabet, let's just quickly talk about what's going to happen in our program. In this example, I wanted to keep things simple and not overburden our application with too many requirements. So for now, we're going to maintain any spacing and punctuation that might appear in the secret message. And we'll do this throughout the entire encryption and decryption process. I'll also be maintaining the case of the letter in the secret message. So uppercase and lowercase will be maintained. In some cryptographic schemes, lowercase is sometimes used to denote the unencrypted plaintext message, while uppercase is used to denote the encrypted ciphertext, but we're not going to worry about that for the moment. We'll just maintain the upper and lower case. And finally, when we generate our deranged alphabet key, we're not going to be doing any extra scanning for matching letter pairs. I'm actually going to leave that up to you for an extra assignment at the end of this video. So now that we have our basic requirements, let's just take a quick look at the outline for the application, and then we can get to coding. So to make this application work, we first need to come up with something to encrypt. For this, I'll be using the phrase, "the quick brown fox jumped over the lazy dog," including the exclamation mark. The reason I chose this phrase is because it's what we call a pangram. This is a sentence that uses each letter of the alphabet at least once. The other reason I like this phrase is because of the repeated word "the." If our encryption is correct, then both of these words should encrypt to the same string value, giving us a quick way to verify that everything is working. So this application will have three helper methods. The first is the build encrypt map method, which we will use to generate our deranged alphabet and set up our encryption key. The second method is the encrypt method, which, as the name suggests, will be used to take our message and, using the encryption key, will encrypt the secret message. And finally, we have the decrypt method, which will do the opposite and take the encrypted message and return to us the original decrypted message. So with that, let's take a quick look at our code setup, and then we can come back to our slides and talk a little bit more about the specifics. So here I've got a setup for our basic application, and right now I'm using the IntelliJ IDE, but if there's another IDE that you feel more comfortable with, then by all means feel free to use that. But as you can see, I've already done a few things to this application. The first is, if we look at the top here, I've created two static character arrays. The first is our alphabet, and in Java, the best way to create a character array of the alphabet is to just create a string of the alphabet, and then use the toChar array method from the string library. I've also created an encrypt map variable right here. Right now it's empty, but you can see that we've also created the character array to the length of the alphabet. So we always have at least one element in the encrypt map that matches to each element in the alphabet. And like I said, I've also created a message here, which is our pangram, "the quick brown fox jumped over the lazy dog." And I just want to start off by printing that out to the screen so we have at least a reference. I'll give it a tag here, and there we go. So the first thing we need to do at the top here is we need to create our build encrypt method for our encrypt map. So I'm just going to do that right now. And since that doesn't exist, I'm going to create the basic method. So let's talk a little bit about how we're going to actually implement this method. So back in the slides, we can start off by just representing our static alphabet and encrypt map variables that we added to the beginning of the class. And we just need to start populating the encrypt map with random letters because this is what is going to hold our substitution alphabet as well as our key. But we also need a way of tracking which letters have already been used from the alphabet so we don't repeat letters in the encrypt map. So one of the first things we need to do is generate a random index so we can select a random letter from the alphabet. Now, while there are many ways to do this, I'm just going to stick with the traditional math.random method, which generates a number that is greater than or equal to 0 but less than 1, and if we multiply that by the length of the alphabet, in this case 26 characters, what we end up with is a number that should appear between 0 and 25. Now we can use this random index to select a letter from the alphabet and place it in the first element of the encrypt map array. This is how we start to build up the substitution alphabet. And now that the letter has been added, we just need to mark the letter as used so that it doesn't get added to the map again. And of course, again, there are many ways of doing this, but just to make things easy, what I'm going to do is I'll create a third integer array called letters used. Again, this array will be the same length as our other two arrays, and it will be initialized with all zeros. In this case, a 0 indicates the letter hasn't been used yet, and a 1 indicates that the letter was previously added to the encrypt map array. So the idea is, as soon as we copy a letter over to the encrypt map, we change the number at the index from a 0 to a 1. The next step is to just simply move our encrypt map index up to the next element and repeat the process. So what happens if our random index generator picks a letter that has already been used? For example, if we were to fast forward the process a little bit, here we can see an example where the index is pointing to the letter B, but we can see that the letter has already been used. In this case, the simplest solution is to increment our index until it finds the next 0 in the integer array. Of course, if we continue this past the end of the alphabet, we can use a modulus to wrap the index back around to the beginning and continue from there. And so long as we implement the code correctly, we should never run into the situation where the letters used array contains all ones when we do our scan, and we don't have to worry about an infinite loop occurring. So with all this in mind, let's go back to the code and see how it's implemented. So here we are back in the code, and so let's just get to building our encrypt map method here. So the first thing I want to do is create a for loop. So I'm just going to create a simple for loop, and we want to make sure that it spans the length of our alphabet. So the first thing we need to do is create our random index. So what I'll do is I'll create a variable here, a random index, and typecast it to integer. So I want to take the math class, the random method, and again I want to multiply that by the length of our alphabet. And this will create a number from 0 to 25 so that we can access any letter within the alphabet character array. And the next thing we need to do is create our letters used array, our integer array, so that we can mark when each letter is used. So what I'm going to do is I'm just going to create an integer array up here. And again, it's going to be the length of our alphabet. So like I said before, we need an edge case where we have to, if we run into a situation where the letter has already been used, we need to scan our letters used array and determine where the next 0 appears in the array. So what I'm going to do is I'm just going to create a little while loop here. And what I'm going to do is I'm going to check if it's 1, what I'm going to do is I'm going to take our index and I'm going to add 1 to it, but I'm also going to use the modulus operator for the length of our alphabet, so that if we end up going over the edge of the alphabet, we wrap back around to the beginning again. And of course, we want to make sure that we take our letter used map here, and at the index, we want to make sure that that value is set to 1, indicating that the letter has been used. And the final thing we want to do is, now that we have our index and now that we've selected, now that we've determined whether or not the letter has been used, we just need to grab that letter from the alphabet and add it to our encrypt map character array. So let's do that right now. And our index, there we go. And that's it. That's all we have to do for our encrypt map. So let's just write those out to the screen. So what I'm going to do is I'm going to write two messages. So I'm going to write the original alphabet. And in Java, to turn a character array into a string, we just create a new string object and pass in the character array. Do that again for our encrypt map, but I will call it our substitution alphabet. And there we go. Now, if we run this, we shouldn't see very much output except for the original alphabet, our substitution alphabet, and our original message. And here you can see at the bottom the alphabet. Each letter matches up to a substitution letter. And if I run this application again, we can see that the substitution alphabet has changed to a different key. So we're basically generating a new key every time we run the application. So our next step is to build our encrypt method. So I'm going to do that right now. So first thing I'm going to do is I'm going to create a string variable that takes in our encrypted message. And what I'm going to do is I'm going to create an encrypt method that takes in our message. And of course, I want to do an output. There we go. So obviously we don't have our encrypt message, so let's build that right now. So in order to encrypt our message, again, I mentioned at the beginning of this video that the way that works is we take each character in our message and look it up in the alphabet, and then each letter of the alphabet has an equivalent substitution replacement in our substitution map, and we take that substituted letter and add that to our string. So to do this, first thing I'm going to do is create a new character array for our new message. And of course, this character array is going to be the same length as our message that we want to encrypt, our secret message. And once again, I just need another for loop. And this one is going to be the length of our message. And once we have our for loop, the first thing we need to do is grab each character from our message and start looking at it. So I'm just going to create a character variable right here. And what I'm going to do is I'm going to take our message, and I'll just use the char@at method right now to grab each character at the specific index. So now we have the character. I mentioned at the beginning of the video as well that what we're going to do for this example is we're going to maintain case for the letter. So that means uppercase is maintained and lowercase is maintained as well. So the first thing I need to do is determine, am I actually a letter? So for that, I'll use the character class isLetter and pass in the C. So before we actually deal with letters, let's just deal with the situation where it's not a letter. As I mentioned, what happens in that case is that the character is just carried through. So what I'm going to do is just handle this simple case right now. And there you go. All we're doing is we're taking the message character at the specific index and passing it through to our message string, if it's not a letter. If it is a letter, we need to determine whether or not it's uppercase or lowercase. So first thing we'll do is character is uppercase, C. And of course, we'll have the case where it's lowercase. Now, if it's uppercase, because our alphabet character array is all lowercase, we'll need to temporarily turn that C into a lowercase. And then what we can do is we can take our new message array here at our index, and we're going to once again turn it back to an uppercase. But this time what we're going to do is we're going to take our encrypt map, and now we're going to need to find an index into our encrypt map so that we can grab the letter, the substitute letter, and put it into our message. So all we have right now is our character, but how do we turn that character into an index? And the best way to do this is if we go back to the slides for a little explanation. So here we are back in the slides again, and as you might already know, text characters on the screen are represented in computers by specific character sets. One of the most popular of these sets is the ASCII character set, where each character is assigned a number from 0 to 127. Now, the first 32 characters of this set are unprintable on a screen, and the reason we have these characters is that they hold specific meanings in traditional text editors. But starting at the 33rd character, we see our first printable character, which is the space character. And of course, this is followed by numbers and letters and other symbols used in the English language. In all, there are 128 characters in this set. And the nice thing about this ASCII character set is that these characters always appear in the same order, no matter which computer or operating system you're working on. And we can use this simple fact to help us to determine how to convert our character that we've selected from our secret message into a proper index that we can use to index into the encrypt map array. Now, as you can see, lowercase letters in the alphabet are all aligned sequentially. So A, B, C, D, all the way to the letter Z. And all we have to do is take our character that we've selected from our secret message and subtract the index of the lowercase letter A. So for example, if the current selected letter from our secret message is the letter P, we know that its index in the ASCII character set is 112. With this, we simply need to subtract the index for the letter A, which is 97, and this will give us an index that we can use to access an element in the encrypt map array. So in code, we want to take our character C and subtract it from the string letter A in order to get an index for any selected alphabetic character from our secret message. So here we are back in the code again. And as I just mentioned, we need to take our character that we selected from our secret message and convert it back into an index. So as I said before, we take our C and just simply subtract it from the letter from the letter A. And there you go. And of course, for lowercase, we do the same thing, except this time we don't have to convert it to uppercase. And the final thing we need to do is just go to the end of our method here, and we need to return a string with our new message. So I've already printed out the encrypted message to the screen, so let's take a look at this if I run it. So as you can see, we've got our original alphabet and our substitution alphabet, but now we've also got our original message as well as our encrypted message. We can see our original message is the quick brown fox jumped over the lazy dog. And as you can see, if we were to take the first letter T in our alphabet, we can see that that matches up with the letter W. And that's what we have here. The letter H is matched up with the letter Y. The letter E is matched up with the letter C, and so on and so on. And we also know that the two words the match up in their substitution, so we know that this is working. So there you go. We have our encryption. All that's left now is to do the decryption. So decryption, like I said before, is pretty much the same as the encryption, except in the opposite direction. So with decryption, we start off with an encrypted message, and we convert that back into our secret message. So to start off, what I'm going to do is I'm just going to create a quick variable here called decrypted message. And I'm going to create a method called decrypt. And of course, that's going to take in our encrypted message that we created before. And then I'm just going to output that to the screen. I'll just change a few things around here. And the last thing we need to do is just create our method. So the decrypt method is very similar to the encrypt method. So what I'm going to do is I'm just going to take a little bit of a shortcut here, and I'm going to copy and paste the code from the encrypt message and just cut a few pieces out. So the logic is going to be a little bit different. So let's just take this out, this out, this out. And we can keep those as long as we change these to the encrypted message. There we go. So the first thing we need to do is create ourselves a character array that we can use to hold our decrypted message. And again, it's going to be the length of our encrypted message so that it matches. So let's take a look at how this works. So once again, we have to determine whether or not each character that we select from our encrypted message is a letter. If it's not a letter, then all we do is we pass it through to the decrypted message. So we can do that right now. And if it is a letter, once again, we determine whether or not it's an uppercase or lowercase. So what I'm going to do is, first of all, I'm going to, if it's an uppercase, I'm going to convert that into a lowercase. And then what I need to do is I need to create an index which looks up the index of the character that we've selected from our encrypted message, looks up that character in the substitution map, and uses that index to grab the letter from the original alphabet. And the easiest way to do that is just to create ourselves an index variable. And what I'm going to do is I'm actually going to use the string library for this and use our encrypt map. So index of is a very useful method here where we can basically look up a character, the first instance of a character within a string, and that's what we'll do here. So again, we're basically looking up where that character is in the encrypt map and using that index to grab ourselves the letter. And that means all we have to do now is take our letter and look it up with our index variable. And of course, because this is the uppercase scenario, we have to take that into uppercase and convert it to uppercase. And the lowercase scenario is the same as these two right here, where we create ourselves an index again, but this time we just don't bother with converting it into an uppercase. And finally, the last thing we do is we just return ourselves the decrypted message. Let's take a look at what we have when we run our program. So what do we have? We have our original message, the quick brown fox jumped over the lazy dog. We have our encrypted message, which is scrambled, but still maintains the spacing and the punctuation. And once we do the decrypt, we can see that we got our original message back, the quick brown fox jumped over the lazy dog once again. So there you go. That's how we create a simple substitution cipher using the deranged alphabet in Java code. Now, of course, there are still several ways to improve the application. As I mentioned before, I wanted to keep this demo very simple. I didn't want to overburden it with too many features, but rather than show you how to implement those extra features, what I'm going to do is I'm going to leave them here for an assignment so that you can try these out yourself. Now, don't worry, I'll talk through each item so you know what needs to be done, and then afterwards you can take those ideas and try to turn them into code. So the first assignment is to scan the generated substitution alphabet for any matching pairs and either swap or shift the pairs. So there are a couple of cases that I want to talk about. The first being what happens when you find only one matching pair. In this case, you've got two choices here. The first is you can just leave it alone. You know, having only one matching pair in your substitution alphabet represents a very insignificant difference in the strength of the encryption. Or, if that doesn't work for you, then you can also randomly choose any other index in the alphabet and just do an easy character swap. The choice is really up to you. If you do find 2 or more matching characters in your substitution alphabet, then the solution here is just to do a simple shift with the matching letters. So in this example, the letter E is moved under the letter J is moved under the N, and the N wraps back around so that it's now matched with the letter E. So the second assignment is to take an encrypted message and remove any spacing and punctuation. This can be done inside the encrypt method in our program, and what happens here is if it's not a letter, we simply throw it out. This will also be useful as a stepping stone for the next and final assignment. And in the final assignment, what we're going to do is modify the encrypt method one more time to include a parameter that allows us to specify an arbitrary amount of spacing in our encrypted message. We can start off by taking the encrypted message with no spaces that we created in the second assignment, and then we create a new string with spacing at the specified interval. If the last group of characters is not a perfect multiple of the spacing, then you can optionally include extra padding at the end of the group to round it out, but I'll leave you to decide whether or not you want to perform this last step. So once again, here are your assignments, and you can use these to help practice and improve your understanding of simple substitution ciphers. So hopefully in the next video, I'll have an opportunity to talk to you about some of the theory behind common attacks to the simple substitution ciphers. One of these attacks is what's referred to as a frequency analysis. But for now, thank you for watching this video, and I hope to see you the next time.